Assalamu alaikum. So this is Astable multivibrator made by me, and this is the circuit diagram for this circuit. And for this circuit, I have taken this BCC. It's actually 5.7 volt, which has been taken from this battery. Well, and this RC, you can see RC is 1K and RB is greater. It's 33K. You can choose whatever you want, but take RV many greater than RC. Okay, so now one problem I face that this is electrolytic capacitor, right? This is are not this kind of ceramic capacitors. This is ceramic capacitors, but this is actually electrolytic capacitors. So electrolytic capacitor have, you can see, one leg is taller and another leg is shorter. You can see, so taller leg should be always connected to the positive terminal and shorter leg to the negative terminal. But here in my circuit, sometimes capacitors this leg is positive and sometimes capacitors this leg is positive. So I face some problem because sometimes this is positive and sometimes this is positive, but I can change manually, sometimes here like this and sometimes like this. So what I have done, that you can see, though I have here two capacitors, but practically I have used four capacitors. So why I did this, you can see that I have made these two capacitor into one single capacitor. I have connected the capacitors like this in series. You can see I have connect two positive terminals or two taller legs together and connect it into series, and that's why you can see these two capacitors are actually acting like one capacitor, and similarly these two capacitors are acting like one capacitor. And if I connect these two capacitor in series, these two are 100 microfarad capacitor. So if I connect two 100 microfarad capacitor in series, then in series it will be divided by 2. That means equivalent capacitance will be 50 microfarad. So now this is the formula: time for one LED stays on. That means the duration for which this LED is turns is in on position. So the formula looks like this. This RB is this RB. You can change this RB whatever you want, but take RB greater many greater than RC. And this C actually 50 microfarad, as I have mentioned you previously that I have used, this is 100 microfarad and this is also 100 microfarad, both are in series and making this C. That means 100 and 100 in series, that means equivalent capacitance is 100 divided by 2, that means 50 microfarad. So this is the time 1.14 for which one LED is in the on position. So if you want to find the square waves time period, so this is 1.14 and this is also 1.14. So if you multiply this thing by 2, then you will get the time period of that square wave. Now let me tell you some interesting facts. So here you can see that both are on for the same duration, but if I place my hand here, you see something is happening, something, my body is something affecting this thing. Okay, now let me again place my finger here, place my finger here, and you see something is happening, right? Okay, so put your finger away from these capacitors.